Boys and girls, we have a doubt session today, and a lot of you performed in the test very nicely, and most of you have done well, reasonably well, and as I always believe that we are competing with our own selves, and we keep growing, we keep learning, and keep improving our own selves. Boys and girls, these are the doubts that I received from students. These are the question numbers. If apart from this thing you have any, I will include all these in the doubt session. In question number 2, he says the electric flux through a hemispherical surface of radius r placed in a uniform electric field of intensity E parallel to the x-axis of its circular plane. Basically, he is asking us to determine the electric flux through the hemispherical surface. If this is the plane surface and this is the hemispherical surface, and these are the electric field lines, he is asking us to find the electric flux through the hemispherical surface. As the electric field lines on the hemispherical surface are having different angles at every point, therefore it is difficult to calculate the flux. But we all know that the amount of field lines entering the surface, entering the plane surface, will be equal to the amount of field lines leaving the curved surface. Therefore, the flux through the hemispherical surface is the same as the flux through the plane surface. The flux through the curved surface is the same as the flux through the curved surface, which is pi r square into E. Just a tricky one, but very, very interesting. Next is question number 3. He says, question number 3, are we sure that this is a doubt? No, I think 5th was a doubt, not the 3rd, but the 5th. He says, a hollow charged metal sphere has a radius r. The potential difference between its surface and a point at a distance 3r from the center is V. This means that according to question, Q by R minus Q by 3R is equal to V. This is given to us. He asked us to determine the electric intensity at a distance 3R. Therefore, electric intensity at a distance 3R is Q by 9R square. This will give me, 1 minus 1 by 3 is 2 by 3. 2Q by 3R is equal to V, and the value of Q we will substitute here. The value of Q is 3RV by 2, 3RV by 2, thus giving me V by 6R. It was just a substitution, direct questioning. I hope the video is working, Okay. Then we have question number, this was question number 5, question number 8. Question number 8 says that the radii of two spheres are A and B respectively. They are at equal potentials. Let the charges be Q1 and Q2. Therefore, Q1 by A is equal to Q2 upon B. From here we have Q1 by Q2 equal to A by B. He is asking us the ratio of the surface densities. Surface density of A, surface density of B. This is Q1 by 4 pi A square into divided by Q2 by 4 pi B square. 4 pi cancels out, and we have Q1 by Q2 as A over B, and this is B square by A square, thus giving me B by A. The ratio of the charge densities. Then we have question number 13. He says, along the x-axis, 3 charges, Q2 minus Q and Q by 2, are at x is equal to 0. Let this be x is equal to 0, and you have a charge plus Q by 2 here. You have a charge minus Q at x is equal to A. At x is equal to a, you have a charge minus q. And at x is equal to 2a, yani at another distance a, you have a charge plus q by 2. Right? The electric potential at a distance x is equal to a plus r. Let this be the point P, and this is the distance x. From O the distance is a plus, x is equal to a plus r. This is r. And this entire distance is x. X has nothing to do with it. For a, very much less than r. Okay. But then what is the total electric potential at the point P will be the algebraic sum of the electric potentials due to the individual charges. The net electric potential is going to be K Q by 2 into R plus A. R plus A. Then we have minus Q by R plus Q by 2 into R minus A. This K is outside. This is K, Q. The LCM over here is going to be 2R into R square minus A square. Thus over here we are going to have R into R minus A minus R square minus A square into 2 plus R into R plus A. KQ R square minus RA minus 2R square plus 2A square plus R square plus RA upon 2R into R square minus A square. Let's cancel them out. This is R square and R square, 2R square. This is minus 2R square, and minus RA goes with plus RA, and we have KQ 2A square over 2R cubed. For R square, for R very much larger than A, we have R square minus A square as simply R square over R cube again, and the result is KQ. V is equal to 1 over 4 pi epsilon naught QA over R. Thanda dimag. This was question number 13. Question number 15. This is very interesting. I'll read out the question to you in a very careful manner. A non-conducting ring of radius 0.5 meters, a non-conducting ring of radius 0.5 meters carries a total charge of 1.11 into 10 raised to the power minus 10 coulombs, distributed non-uniformly on its circumference, producing an electric field E everywhere in space. The value of the negative of the line integral of the electric field between infinity and O. L is equal to 0 being the center of the ring. Basically, he is asking us to determine the electric potential at the center of the ring. Remember, the electric potential at the center, the electric potential at any point is the negative of the line integral of the electric field between infinity and that point. It is a simple one. Simply by definition, हर साल प्रॉब्लम आती है बच्चों. Q is 1.11 into 10 to the power minus 10 coulomb, and the radius of the ring is half a meter. Therefore, electric potential at the center is V is equal to 9 into 10 to the power 9 into 1.11 into 10 to the power minus 10 upon half. This will give you 2 volts. We have question number 24. He said a small conducting sphere of radius r is lying concentrically inside a big hollow conducting sphere of radius bada. The bigger and smaller spheres are charged with Q and Q. You have charge Q here, you have charge Q here. And are insulated from each other. The potential difference between the spheres is this is the point A, this is the point B. It is very simple. The answer was wrong in the answers that I sent you. एक और भी गलत है. The only potential difference between A and B will be due to the charge छोटा q. The only potential difference will be due to the charge छोटा q. Because whatever electric potential is at B due to the bada charge q, the same electric potential will be at A due to the bada charge q. Right? Thus, the only potential difference is between A and B is due to the charge q, which is going to be K into Q by R minus Q by bada. That is your answer. Next we have question number 25. He says three charges, each plus Q, are placed at the corner of an isosceles triangle ABC. With sides BC and AC being isosceles, BC and AC are equal, BC equal to AC. He says D and E are the midpoints. This is D, this is E. Right? And we have charge plus Q here, we have a charge plus Q here, and we have a charge plus Q here. The argument is that the work done in taking a charge Q from D to E, now electric potential at D, due to these three charges, Q by A, Q by A and this altitude. And the electric potential at E is also going to be Q by A plus Q by this altitudes. And these altitudes are the same. Therefore, electric potential at D and E is the same. As VD is equal to VE, therefore work done to take any charge from D to E, from D to E is 0. (26) The variation of potential with distance r from a fixed point is shown. V r. This is 10 volts. This is 2, this is 0, this is 1, this is 4, this is 6. This is in meters. Both in case between r is equal to 0 and r equal to 2, the potential is changing equally in equal distances. Thus the field is uniform. The electric potential remains constant between r is equal to 2 and r is equal to 4. Electric potential means electric field is 0. The electric potential decreases. It means, but the variation is a straight line. It means the electric field is again a constant but has a reverse direction from the previous value. Now the value of the electric field is E is equal to minus of V2 minus V1 over R. Minus of. He says field at R equal to 1. The field from in the region R is equal to 0 to R is equal to 2 is an absolute constant. You can find the slope of the graph. This is equal to minus of 10 minus 0 over 2 equal to minus 5 volts per meter. पोटेंशियल का चेंज होना इलेक्ट्रिक फील्ड होता है. It is the rate of change of potential. Electric field at any point is given by the rate of change of potential at that point. If the electric field is constant, the rate of change of potential is constant. If the electric field is zero, the rate of change of potential is zero. The potential is constant. Field is zero, rate of change of potential is constant. Field is zero, potential constant, rate of change zero. The word electric field is a synonym with rate of change of potential. Electric field at any point is the negative of the rate of change of potential at that point. The negative sign means what? Yaad hai? That the direction of electric field is that of decreasing potential. We have question number 27, 29 and 30. Can I rub the board? Question number 27. An electric field is spread uniformly along y-axis. Right? The electric field is spread along y-axis. Consider a point A as the origin. Okay, this is the point A. The coordinates of point B are 0, 2. 0, 2. This is the point B and its coordinates are 0, 2. The coordinates of point C are 2, 0. This is the point C and its coordinates are 2, 0. Very interesting problem again. Basics. Which is correct? Janab, abhi to bola. Direction of electric field is that of decreasing potential. And the plane that I have drawn, this axis, is an equipotential surface. Because electric field lines are perpendicular to an equipotential surface. Thus, it is clear that VA is equal to VC, which is greater than VB. Simple, basic. बड़ा आसान टेस्ट डाला मैंने आपको वैसे. Question number 29. Theoretically हो जाएगा. A big hollow sphere is charged to 100 volts. You must have given some charge, right? The electric potential is 100 volts. It must have some charge, say Q, right? And another small hollow sphere is charged to 50 volts. उस पे भी charge होगा. If B is put into A, if B is put into A, when they were independent, you know, we had this Q and the electric potential at A was 100 volts, right? We had this small one, B, charge Q, and depending on its geometry, the potential was 100 volts, the potential was 50 volts, right? Had we joined them outside only, had we joined them here, charge would have flown from higher potential to lower potential. When I say flow of charge, I mean positive charge would have flown from higher sphere to the chota sphere. But he says that he has enclosed the chota sphere inside the bigger sphere. Now, the electric potential at B will also be due to this charge Q. And the electric potential at the point A and B, due to the charge Q, the electric potential will be higher at B. We know that if we join it by a wire like this, the entire charge from B will flow to A, because potential बराबर ही तब होंगे. If any charge remains on the inner sphere, this would mean that there is a potential difference, and if the two have been joined by a wire, charge flows from higher potential to lower potential till the time the potential becomes the same. Entire charge will flow. In the last question, there was a small error. Actually, the answer should have been marked as C. The lesser than symbol is missing there. B लिखा हुआ है, बिल्कुल ही गलत है. I will revise. You have a charge Q here, and you have a sphere here, A. All points on A are at the same potential. It's an equipotential surface. B. This is also an equipotential surface. All points on B are at the same potential, but VA is more than VB because the electric field is directed in this direction. He says there is another sphere C, and if this difference is T1 and this difference is T2, we have a point C here, okay? Okay, here. And it is given that VA minus VB is equal to VB minus VC. There exists the same difference in potential between A and B and between B and C. The field is due to a point charge plus Q. This means as we move away from the charge plus Q, the rate of change of potential, electric field, that is the rate of change of potential, goes on decreasing. For the same decrease in potential, the distance has to be more. Thus, T2 must be greater than T1 or T1 is less than T2. Please see that this finishes our discussion for today. It was a simple test, but I had stuck to my basics, and let's say today evening I'll give you another one, and it will include electric field also. Electric field, Gauss theorem, electric potential, right? It's a simple one. Mat daro, ho jayega. Can we start with the capacitors today? Let me see how much time did I take for this. Oh, it has taken just 22 minutes into the lecture. I've just disturbed the board. So anyway, I just hit my foot, you know. Okay. Boys and girls, let me start with something very, very interesting called capacitance. And I believe that it will take us through the week. I hope the lecture is working. I must check. Okay. Capacity or capacitance. Boys and girls, the word capacity, okay, the ability to store charge. The ability to store charge. If I have a glass, ml, okay, a 200 ml glass, it could be a Coke or a Pepsi bottle, खाली की कैपेसिटी ज़्यादा है कि भरे हुए की? कैपेसिटी दोनों की सेम है. Capacity is 200 ml. Whether it is empty or filled is of no consequence to us. If we keep on adding some liquid into it, the level will go on rising. And its capacity would depend upon the shape and size and not on the material. A 200 ml bottle made of plastic or of glass would be 200 ml. Whether it is empty or filled, it will be 200 ml. It will depend upon the shape and size. Coming to electrostatics, the capacity, the ability to store charge will depend upon the shape and size and not on the amount of charge. No doubt, जितना हम चार्ज दे जाएंगे उतना उसका पोटेंशियल बढ़ता रहेगा. Electric potential is defined as the amount of work done to bring a unit positive charge from infinity to that point. Suppose we have to charge a conductor. We cannot just charge it at once. It has to be given in installments. But we won't do that. But we know that जितना चार्ज आपा किसी कंडक्टर को जितना चार्ज दे जाएंगे, इंसुलेटर को भी जितना चार्ज दे जाएंगे उतना उसका पोटेंशियल बढ़ता रहेगा. Thus we will start from here that as we charge a conductor, charge a material, as we charge a material, its potential goes on increasing. Its potential goes on increasing. Therefore, Q is directly proportional to V, or Q is equal to C into V, where C is equal to Q by V is called the capacity, or simply capacitance. Capacity depends on shape and size and presence of surrounding charges. As we keep on studying the topic, we will understand this step. Shape to samajh aa gaya. Actually, if there are some neighboring charges placed that can affect the potential, if the potential gets affected without affecting the charge, the capacity would increase. Anyway, आगे पढ़ेंगे तो और समझ आ जाएगा. What would be the? अच्छा, एक और बात. Depending on its shape and size, if we go on adding charge to the conductor or to the material, its potential can rise up to a certain limit only, which is called its capacity. If we have a 200 ml bottle, you keep adding liquid to it. Its level will keep on rising, but if it gets completely filled, the liquid will begin to overflow. Similarly, depending on its shape and size, depending on its capacity, you can charge a conductor or a material to a certain potential. If you try to give it charge more than its capacity, you are trying to raise the potential more than it really can be raised. Thus, charge will also begin to leak. Thus, you can raise the potential of a material by charging it, but that amount of charge and potential would depend on its capacity. Units. 1 coulomb over 1 volt, called 1 farad. Called 1 farad, or simply 1 farad. Now farad is a very large unit, just as 1 coulomb is a very big amount of charge, but it is the SI unit. That is why we will have capacities of materials, spheres, plates in terms of microfarads, picofarads. 1 farad is a very large unit, but still if we have to define it, we will define it as the capacity of a conductor is said to be, 1 farad if a charge of 1 coulomb brought on its surface will raise its potential by 1 volt. The capacity is said to be 1 farad if a charge of 1 coulomb raises its potential by 1 volt. I repeat once again, you can write it down if you want to. The capacity of a conductor is said to be 1 farad if a charge of 1 coulomb raises its potential by 1 volt. Farad is a large unit. Note आगे लिख सकते हो, farad is a large unit. Capacity of an isolated conductor capacity of an isolated conductor. Consider a sphere of radius r. We charge it लैंग्वेज थोड़ी इंप्रूव कर लेते हैं. A charge given to it raises its potential by V volts. Electric potential at the surface is V is equal to Q by R in CGS and V is equal to 1 over 4 pi epsilon naught Q by R in SI. Therefore, capacity C, which is Q by V, is Q by R equal to R. The capacity of an isolated conductor is numerically equal to its radius, or C is equal to Q by 1 over 4 pi epsilon naught Q by R, giving me 4 pi epsilon naught into C is 4 pi epsilon naught into R. Boys and girls, C is Q by V. If I increase Q, C को क्या होगा? कुछ नहीं होगा. Q डबल कर दो let's say, V भी डबल हो जाएगा. Actually Q is proportional to V. C depends upon the shape and size. It does not depend upon Q or V. Actually, Q is proportional to V. You can raise the potential by charging the conductor, but only up to its capacity. The more we do, the more we learn. Okay, let us determine the capacity of the earth. Okay, let us determine the capacity of the earth. The earth is a sphere of radius 6,400 kilometers. C is equal to 4 pi epsilon naught into R. 4 pi epsilon naught की क्या वैल्यू होती है? 9 into 10 raised to power 9 नहीं होती. नहीं होती. 1 over 4 pi epsilon naught is 9 into 10 to the power 9. Therefore, this is going to be 1 over 9 into 10 to the into 6,400 kilometers into 10 raised to the power 3. This is itne farads, and this is 400 39964. Yeah, this comes out to be 711 microfarad. As you all know, मैं calculation बहुत तेज कर रहा हूँ. Thus, the Earth, which is a sphere of radius 6,400 kilometers, has a capacity of 711 microfarads. Just imagine, can you determine the radius of a sphere whose capacity is 1 farad? Oh my God, it could engulf the Milky Way. बहुत बड़ा sphere होगा. Unimaginable. अविश्वसनीय. Please see that farad is a very large unit. We have started with capacities, and tomorrow we will do something called a capacitor. Please see that you have nothing to do today. I will surely give you a small assignment of 30 questions. Come on, boys and girls. Bye-bye.